I welcome and thank each one of you for joining this event by Cloud Native Riyadh. First of all, let me introduce the Cloud Native Computing Foundation. CNCF is a non-profit Linux foundation that focuses on open source tools. CNCG Riyadh is a Riyadh-based chapter of CNCF. And we had our previous sessions on the Cubastronaut Journey by Saleh Ashlaman, and we got an overwhelming feedback to these. And this is going to be our fourth session. At this moment, I would like to extend my gratitude towards our event sponsor, StackGenie, a platform management service provider based in the UK and USA. So, I would like to welcome our speaker, Mohammad Fazlullah, for today's event. I also welcome all the organizers, all other guests who have joined for attending the event. So, before moving on to today's topic, simplifying your Kubernetes infrastructure with cdk8s, we have with us Mohammad Fazlullah, a senior developer advocate at AWS for the MENA region. He educates and empowers developers on achieving cloud capabilities. He's an architect and a technical evangelist. He speaks on various trends in the technology space with a focus of building and scaling in the cloud in and around Asia. He has designed and built products for over 18 years in the enterprise and SME space, along with building engineering teams and helping them scale. Hereby, I welcome Mohammad Fazlullah for the talk. I welcome you.
Awesome. Thanks, Parvati. Thanks, everyone. And thanks to everyone who's joining in on a Thursday evening, because Friday, Saturday is the weekend. I keep forgetting I'm actually from Dubai, so I keep forgetting that Saturday, Sunday, we took the weekend away from Friday. And yeah, I mean, awesome. Thanks, everyone. Thanks for joining in this session today. I am Mohammad Fadlullah, also known as Faz. A lot of folks surprisingly still don't know how to pronounce my name. I've been having that for the last 40 years throughout my career in various parts of the world, so I just keep it short wherever I need to. I see some familiar names in the chat also, so thanks for joining. And for folks who see me for the first time, thank you so much for joining the session. And I'll give a bit of a brief on why this session is important, right? This whole idea of trying to simplify how much of work we put into setting up and even managing things on Kubernetes. I've deployed a certain set of Kubernetes clusters already for some time throughout my career. But predominantly, it's been, especially in the last few years, with AWS. I've been over 5 years in AWS. It's all been about, helping customers to do that, trying to show how they can, build it properly. And one of the things that always comes to us from customers is that, okay, great, we chose to use Kubernetes for whatever reason, right? Somebody said, let's use Kubernetes, and then we chose to put it on AWS, and that's great. But we are spending a lot of time trying to just manage all these configuration files, manage all these YAML files, and then now we are also trying to get into this GitOps space, or trying to build a GitOps pipeline so that we can deploy changes to our cluster at the same time when we're trying to deploy other things also. So, is there any way to make it easier so that we don't have to spend a lot of time into like writing YAML file and then after doing other things with code? And more or less, a lot of those questions came around, okay, is there a way to abstract it by giving developers or builders tools to actually manage Kubernetes clusters when they're provisioning certain things, right? So that they don't have to learn a new construct or a new format in YAML. Because guess what? With YAML, yes, it's a key value pair file that you can provide, but for every implementation that you do, whether it's like, let's say, it's for a build tool, maybe in the JavaScript ecosystem, or maybe using it for like some configurations as part of CI/CD pipeline, or if you're using it for manifest files, every time the YAML file syntax is always going to change, right? So just knowing YAML doesn't help a lot in that sense, and that's kind of like where cdk8s actually comes in, right? And to set the stage, this is kind of like where we see with the kind of implementations that are happening globally right now. So we have from 2022, in 2022, there was a massive jump from 2021, right? Many organizations decided to deploy more than 50 clusters in one organization, right, in one company. And there's various reasons they do that. Sometimes it's for trying to make sure that they have enough number of environments that are replicating production, right? So think development, think staging, think maybe load testing, for example. So a lot of times they use multiple clusters for that. They try to make sure that they, isolate those clusters from each other. But there's only less than 12% of organizations that deploy 5 clusters or less. The question still remains, right? Why Kubernetes? There's a lot of other things that are already out there. If you're as old as me in the industry, you probably would remember that when Kubernetes came out, there were already other things that were vying for attention in the container orchestration space, right? So think Docker Compose, for example, think Mesos, for example, a lot of other things. And more or less, Kubernetes over the years became stronger, massive community, and a lot of adoption across from startups all the way to enterprises, all the way to public sector and government. And it kind of gave that it steamrolled most of the competition, to be honest, and also showed a way of trying to have this uniform approach for creating APIs and creating structures. But the key thing to understand is that you need, I mean, for anyone who's still on the line of how to decide whether they want to do containers, right, on Kubernetes, is that there is a need for container orchestration or management systems, because you need to make sure that you have a certain way to interact with these things, especially if it's a uniform API, if it's an API that you can actually talk to and you can build tools around. Also, the fact that you want to make sure that you're able to provision and manage containers without going with the heavy lifting of trying to, go down to the compute level, go down to the network level or the storage level. So you want to be able to just place a container and then make sure a system figures out how to, best put that in based on the configuration that you set in, right? How many nodes you want, how the availability is going to be like, and a lot of other things, what the ingress and egress is going to be like. And also the open source flexibility, right? The fact that you can plug in multiple tools, multiple plugins that will enhance the capability of what you're actually trying to build with your container ecosystem. And that's kind of like where Kubernetes kind of comes in. Now, one of the ways that when you get started with Kubernetes, the way you actually start deploying things is that you will use manifest files, which are basically YAML files, right? And everyone, I say to everyone, if you, whatever programmer you are, we are all YAML engineers at the end of the day, right? We all do YAML, whether I'm a Java developer, whether you are like from Node.js or from Python, we're all still YAML engineers at the end of the day, because we are doing some YAML somewhere or the other. And it's universal, it's a declarative desired state, right? This whole idea where in the manifest file, you say, okay, this is what I want, and then the system in which you apply those files will then move to that state, that desired state, unless some errors or something creep in like later. And it's a very static file, right? You don't change the file dynamically when it's actually applied to, like, let's say Kubernetes cluster, for example, in this case. So it's easy to understand. And you can manage a lot of resources inside this, and of course, you start usually with one manifest file and then you split it out. You try to create one for services, one for deployments, and then so on and so forth. And then you start looking at, okay, what are best practices in terms of that. But just quickly at a high level, YAML is very easy to start, right? It's easy when you have very few things, like very simple cluster you want to, like manage. Like let's say on Minikube, or you're using K3s or something on like an EC2 instance or on a virtual machine online. But the moment it grows, it gets harder, right? It starts promoting this whole idea of copying and pasting. And I'm sure some of you may have already seen this, where let's say you come in and then afterwards you introduce a certain way of using YAML files or managing the manifest files for Kubernetes clusters in your environment or in your organization, and then you share it with other people, then they will start tending to, copy pasting certain things and then putting it in. And then when you have to go and change, like, okay, I think there's a certain way to write this better, and then you change that. Now someone has to go and figure out all the other YAML files that are there, and then go and change all of those formats in that case. The other thing is that customizations are very manual, right? Like I said, Control Shift F, search across the project if it's in the same project. Or you may require special tooling, which there are some tools that are already available. Updates across all these multiple files can actually be complex, right? Yeah, and I'm having a bit of a stuffy nose right now, so if I sound a bit off, it's just because of that. Now there are ways you can actually do this right now. There is a customize that's available. So this helps you to implement best practices, like don't repeat yourself. This allows you to create things like for staging and for prodding, for prod environments, and you can do patching and easy to manage. The challenge is you still have to do YAML, right? In this case, because you still need to make sure that you're writing everything in the YAML file. So again, it's another syntax. Think of it as syntactic sugar on top of manifest files on top, but it still helps you a bit better, and that could probably work for you for some of the use cases. But the moment you want to do more and then scale this across teams and organizations, that it does become a challenge. And you can probably put it in the comments later. Also, once you see about cdk8s and all, I'm not sure if any of you have actually been using it or have been looking at it. So we'll probably get to that at the end of the thing. Now, beyond this, you also must be using Helm, right? So Helm is basically, if you want to deploy services, it's a package manager for Kubernetes in general. It's still based on YAML, right? But it also allows you to build Go templates, right? So you write Go templates, which can then have conditions inside, because of course it's using a programming language, but it's still YAML end of the day. And the challenge right now is that with Helm, when Helm is basically exploded on the scene. Every time you want to integrate or bring anything into your Kubernetes clusters, you will probably be using a Helm chart, and it has worked until a certain point, after which people have been looking at, okay, is there a way to reduce the complexity and the dependency on certain approaches to Helm? The other challenge that comes is, especially from a supply chain perspective, which of course is with any given package manager, the fact that I'm using a chart from someone or somewhere outside in the internet doesn't necessarily mean that it's always secure, which basically means that you need to also have that additional capability of doing vulnerability scanning across packages and other things, or trying to maintain a certain way of running your own repositories of some sort. So that something like that also comes with help charts. Of course, Bitnami is there, that you use that, and there's a lot of other like providers which are trusted. But then again, it's always something to keep in mind in that case. And this is kind of like where the question comes from developers in general, because you'll be surprised to know a lot of developers also have to use Kubernetes in some form or the other, right? Either it is on their local laptops as part of testing their container ecosystem, container applications, containerized applications before they deploy it into like staging or give it to a DevOps team, if there is a DevOps team in your organization, or the fact that they have to own it and run it. So that they are trying to say, okay, how can I minimize the number of moving parts? How can I make sure that whatever language I am using, the programming language for my application, can I use the same programming language to also manage my Kubernetes clusters, right? Manage the configurations and the provisioning of those resources, and that's kind of like where this whole idea of cdk8s comes in, right? So this is basically, uh, expand the definition, it's basically cloud development kit for Kubernetes, right? So CDK is actually a project, and I'll be talking a bit about that in a few slides, just to give you a context of where CDK comes in first and how it's related with cdk8s. But cdk8s is an open source framework. It's actually a sandbox project in the under CNCF. It was submitted, I think, 2 years ago, or 2 or 3 years ago, as a sandbox project, and it's still there. And it is fairly being used. We've had some customers come up to me and come and talk to me about how they would want to take stewardship of cdk8s, like Adobe, for example, and others. A lot of this was like 2 years ago when I delivered a talk on cdk8s at reInvent, which is a big conference that happens in Las Vegas in the US. So we have a lot of customers who come in and they're interested, and then they talk about this. Of course, I mean, interest is one thing, but then when it actually comes to implementation, it's a different story altogether. But they are interested because it shows that there's a certain approach to trying to solve this problem of having a similar programming language or an approach to managing managing all the manifest files without actually writing any YAML files. So quickly, just to give you context for CDK, this is an open source multi-language software development framework. This is also an open source framework for modeling AWS cloud infrastructure as reusable components. This is specifically for the AWS cloud, but cdk8s is not. cdk8s is something you can use immediately and on your laptop, even for a minikube cluster which is running over here, or for any cluster, whether it's on-prem or in the cloud, any cloud for that matter. But just to give you an idea, CDK is an open source software development framework, so you can use multiple languages to write infrastructure stack as code, right? So you can use Python, you can use JavaScript, TypeScript, C Sharp, and Java. And the whole idea is that you can define what your infrastructure should look like as part of code, and you get all the nice stuff of adding logic and then doing linting, and then trying to use tools that are familiar with in the IDEs, for example, autocomplete, inline documentation, debugger, and all the so on and so forth, right? Because what it does in the end is that once you write your application code, your CDK code to build that infrastructure, you can then synthesize it and then it will spit out a YAML file, right? Of course, it's YAML in the end, it's a for the other. And if you are familiar with AWS, you would know that we use CloudFormation for any infrastructure automation. So what CDK does is it gives us a CloudFormation template in YAML, which you can then apply, right? You can then do a deploy to. So if you do a CDK deploy under the hood, it gives you a CDK synth, and then after that, which I'll kind of show in a bit. And to give you an idea of verbosity of what it is, right? So here's an example in CDK. So what I'm doing is, all I'm trying to do is I'm creating I'm creating a virtual machine inside a VPC, right? So I'm in the code on the left side, you have like the stack, which basically is the definition of what this deployment should look like. So it's a stack, and I have an EC2 instance that needs to be created through VPC. When you do this in the code, and then you do cdk synth in the command line, it's going to spit out this whole CloudFormation template on the other side in JSON or in YAML. And the whole idea is that you can then have these default values as part of that when you create this, or you can add your own values if needed. But the whole idea is that you get an opinionated stack from the get-go, so that you don't actually have to go and create this template by hand yourself. So you can see that a lot of work is being put in behind the scenes to make sure that you can just focus on creating your infrastructure as code, literally, and then afterwards handing it over to a tool like CDK, and then afterwards it then helping you out in terms of creating that template, and so on and so forth. And that's kind of like what the workflow is going to look like, right? So you have the CLI, which you will install. It's usually it's with npx, and afterwards you'll create a project. So you do a CDK init that gives you a boilerplate code, and then you can then write the code. So you create stacks, you create constructs. So you have different levels of constructs. We won't go too much into that in this case because you don't need to know too much about CDK to actually use cdk8s, but it's useful because you can actually clump both together, as you'll see in the demo later. And once you have that code ready, stacks and constructs, you can then do a CDK synth, which then gives you synthesizes the CloudFormation templates and any assets that are available. And then you do a CDK deploy. And when you deploy that, it then deploys and then provisions the resources. Think EC2 instances, think like API gateway, EC2, like ECS containers, for example, or even an EKS cluster, which is what we're going to see. And that's kind of like how it'll get started. You can also then publish this as a project, right? So you can publish it as a package inside npm or any other like Python or any other package or repositories that you're using, so that other people can then reuse that. So they can import it, and then afterwards they can use it. And this is very useful, especially when you're trying to create patterns, you're trying to create constructs that can be shared across the organization. So think like, for example, you have like an opinionated approach in your organization to create a VPC stack, right, which has a certain way of having the network set up, the security group set up, and everything else set up. You can have that as a construct, and then afterwards somebody can then just come in and then import it and then start using it as part of the code. That's kind of like how you want to look at it. So this is kind of like the flow in this case. Now with cdk8s, what happens is that this is a development framework, an open source development for modeling Kubernetes resources as reusable components, which again gives you all the niceties of CDK, because the idea is that you can then create reusable components which other people can also use, right? So you have language support, which currently is for Python, TypeScript, Java, and Go. And it's a good way to standardize instead of copying and pasting YAML. And you don't need to install anything on the server, right? On the Kubernetes cluster, there's no dependency that is required, because in the end, what happens is that it's going to spit out a YAML file, which you can then apply directly onto your Kubernetes cluster. And this allows you to then run it anywhere. So this can be used, like I said, for any on-prem cluster. It can be used for any cloud cluster that's used. Anything that accepts Kubernetes manifest files, you can use it over there. And the flow is similar to something like what we saw with the CDK. With cdk8s, you have the CLI, you do an init, you get a project, and then afterwards you write the charts and the constructs. In this case, instead of a stack, it's a chart, and not to be confused with Helm charts. This is something that a lot of people get confused with. It's not a Helm chart. There is a different way to bring in a Helm chart in this. But a chart is basically their way of trying to say that, okay, this is how we are trying to bring all the deployment and the service and everything together in one point. And when you do a CDK synth, you get a manifest file, right, which you can then use as part of kubectl, or you can use it as part of GitOps deploy and anywhere else, which is pretty cool, right? Because think about it, as if you're having a GitOps deployment that's a GitOps pipeline that's already available as part of your application deployment, and if you write your Kubernetes the definition for your Kubernetes infrastructure, right? Whether the kind of resources that need to be spun up, the way your application is going to actually be spun up within the Kubernetes cluster, you write that as code and keep that as part of the code base of your whole application. When you do a build, as part of your build steps, you're also going to have a CDK synth or a cdk8s synth as part of that step, and then it's going to give out the application build, which is for the actual application. It will also give you the manifest file, which then, as part of your GitOps steps, you can then go ahead and start applying it, right, to your Kubernetes clusters that you already have, which is pretty cool. So in this way, what happens is that, again, you get all the stuff of, IDE, autocomplete, debugger, and a lot of other things. And at the same time, you can also do those builds directly and do a synth, and then also have like the basic linting that's available to make sure that, okay, you are creating a manifest file that is valid, which can then be deployed or that can then be applied to a Kubernetes cluster in this case. So in a nutshell, this is how it would look like. And you have an Nginx deployment that's there right now in this. And if you notice, unlike the CDK code that we saw over there, over here you can kind of relate between the files much more easier, right? So there's a Kubernetes deployment I'm creating in this case for Nginx, and as part of that deployment, I am creating a specification. So using a template for Nginx, and then afterwards also having the containers, right? Which container I need to use, and also adding a label as part of that. So if you do a cdk8s synth, you're getting a deployment directly in this case, and then afterwards having the labels added, which is Nginx, having that added to the template also, and then using the standard Nginx container. That's it, right? A very simple, straightforward kind of a deployment that's available that you can then just do a kubectl apply on that manifest file that's available there. Now, we also have another abstraction, which is basically an API abstraction, right? Because with cdk8s, if you notice, there is a lot of information that you need to provide still. So you can start looking at this as, okay, what information do we really need at this case, right? So things like removing, we can actually do things like removing the deployment name. You can remove the labels. You can remove the selectors for them, and have all of this handled by cdk8s plus. And this is kind of like where you can do this, right? The intent basically is that, oh, wait. So the intent basically is that you want to have just the container for Nginx, right? And this is all it is going to do, right? So it's going to use Nginx, it will have the containers, and then image is basically Nginx, and it will use that label of the image that is already there, and it's going to add that as part of the labels directly, right, with cdk8s plus. So this kind of like is an abstraction out of the API. So there are places where you can use this, especially if we kind of see that as part of the demo. It'll give you an idea. But a lot of folks, they usually just get started with cdk8s because in a way, it's a great way to just start visualizing, okay, instead of writing my manifest files by hand, I can start writing it in code directly and then start seeing how I can interact between all these resources that are there. And depending on after the demo, based on the questions, we'll probably ask if in the future someone wants to attend a workshop. And if there's any interest in attending a workshop, hands-on workshop, we can definitely run one in the future. So how do we actually simplify this further? And this is more or less like just to give you an idea that unlike YAML files and manifest files, the moment you start using code to generate your infrastructure code or configuration so that you can then apply it to your resources, this is where you can start using generative AI to suggest things, right? And that's kind of like where Developer comes in. I mean, of course, I'm not going to go too deep into this today. This is going to be a separate session of how you can use something like Developer to make your life easier for developing and deploying for infrastructure. But the idea is that you can actually get help in generating code, right? And you can also do things like security scans, which is right now available for Java and Python applications. There is slowly support coming in for TypeScript and Go, but I believe it's still in preview. You can have a check for that because it keeps changing every day. And also the fact that you can also flag and filter code that resembles OSs. So any code that resembles OSs, you can then say that, okay, I don't want this, and then after that doesn't pull it in as part of your code because you may have a policy in place in your organization for that. But the way it works is pretty straightforward. So what it does is that once you install the extension, you write the code, it starts analyzing it based on the line-by-line suggestions or any comments that you put, inline suggestions, to start adding it in. It'll add a line or it can add a whole block of functions. But of course, you have to review the code. I mean, so you always verify whatever comes in from an LLM or an LLM service. But the idea is that now when you use something like cdk8s, you can actually leverage Q developer also then to when you're writing the code for trying to create some resource in Kubernetes, you can actually leverage Q developer to actually give you suggestions of how you can do that. Cool. So with that, quickly, we are going to start looking at a very simple demo. And the demo is going to be a pretty straightforward application in this case. So CDK is going to, so you're going to see both CDK and cdk8s in action. CDK is going to be used to deploy the EKS cluster because yes, I'm going to be using AWS in this case as part of the demo. And this gives you an idea of how you can actually use, like both of them together, along with, deploying it to a cluster, and also seeing cdk8s plus also in action in this case. So very simple application. You have ingress, you have service, you have pods that are available, and so on and so forth. So with that, let's jump right into the demo. So if you notice over here, and the idea is that I had to do a recording because I was short on time. We probably do a hands-on later as part of the workshop in the future. Now you'll notice this is TypeScript, so this is a TypeScript project, but you can also do this in Python anywhere else. There are imports being done right now for cdk8s and cdk8s plus, right? Now this is a CDK project. I'm going to start with an EKS cluster in the beginning. So if you notice on top, I have a stack that's created, which is basically from a CDK approach. And as part of that stack, uh, below over there, you have like a cluster that is being created, right? An EKS cluster. So first up is the version number that's going to be there. Also, then what are the load balancer controllers that are going to be provided? Because that load balancer from AWS is basically what is going to allow the ingress egress part behind the scenes. Then also to allow Kubernetes a kubectl layer so that I can apply Kubernetes manifest files also as part of this, right? So pretty straightforward EKS cluster definition. Now, as part of adding a Helm chart to this cluster, I'm saying, okay, through CDK, I'm saying, okay, fine, add a Helm chart so that I can then use this within this. Now, there are two ways to do this. Now, this is basically because we're using CDK also as part of the setup. I am actually injecting a Helm chart to the CDK stack directly. But there is another way you can actually use it if you're using just cdk8s. I'll show that through the documentation later. Now I have the Helm chart ready, and I have I'm getting the service load balancer address. So once when it goes through the stack step by step, it's going to start. I mean, when it creates that CloudFormation template, it's going to start creating these things step by step when you apply the CloudFormation template, and then it's going to get that service load balancer address name, and it's going to output a certain the endpoint for that KubeView Helm chart, the KubeView plugin that we talked about earlier. Now, this is where the cdk8s part comes in, and you can actually start seeing the cdk8s code actually being typed out. You're going to see how the Kubernetes workload is going to be defined. And it's a very simple HTTP server in this case, which is just going to have like a welcome message of some sort, right? So first up is that the cdk8s app needs to be initialized. And what we're going to do is we're going to create a new cdk8s app, and this is going to be just a definition of some sort, right? So you're going to have like a Kubernetes apps, and this is kind of like where you're seeing also Q developer in action, where it's giving me suggestions within the IDE also, right? So a nice way to just to complete, especially if you're new to using a framework like CDK does. And now once I have that application definition ready, I'm going to create a chart, which basically means that this chart gives me like a construct to define what is going to be within my application, right? And as part of this chart, I'm gonna say, okay, for this app, which is going to be labeled HTTP Echo, I am gonna actually add just this. I'm not even using the namespace. It's just going to use the default namespace property in this case. Uh, Beyond this, now I'm going to use the cdk8s deployment, cdk8s plus deployment. In this case, because I don't want to add more variables or definitions that are required. So just a straightforward K plus deployment in this case, which is part of the input that we did on top. And this is going to allow, this gives me a suggestion through Q developer that, okay, this is what a deployment looks like. As part of the deployment, I have the container definition and everything else ready. So it's a pretty straightforward container definition in this case. Next up, I need to expose this deployment, right, to the outside world. So what I'm going to do is I'm going to create a service, and as part of the service, I'm going to expose this view service, and I'm going to use the node port type as part of this, right? So it's just going to use this. Now, as you can see that using cdk8s plus allows me to reduce the number of lines or configuration that I need to put, right? Because it's now using a very opinionated approach to actually doing all of this. And sometimes this is more than enough for what we need. But a lot of times you don't. And that's kind of like where you would want to continue using cdk8s directly instead of using plus. Now, with the service type node port also ready, the next step is I'm going to define the ingress, right? And now you kind of see that as a programmer, it starts becoming a very logical thing, right? I'm saying, okay, fine, I'm creating an app, and now I'm creating a service. I'm now doing ingress also as part of this. And if I needed to like point it to a backend, I could do that, or I'll just use default in this case. I can also add rules right directly into this. So I'm adding a rule as part of ingress over here. So anything that goes to root would then go to this ingress backend, right, directly in this case. And just to understand what that backend is, I'm going to invoke that from a certain service that is available. That's basically the service that I created on top, right? The expose via service over here on top. Now, with all of this ready, the other things that are left is that I'm adding the cdk8s chart, which basically means that there is this part where I'm trying to point it to the ingress load balancer, and here this is where I'm invoking back that original EKS clusters load balancer that is already there, right? So that I can get that in that configuration, then adding a dependency, and then afterwards also getting the application endpoint for that actual application, because now we're having two endpoints, right? So we have the application endpoint and also for view for cube view chart also in this case. So now I'm doing a cdk synth. This allows, and if you notice that it's basically using npx behind the scenes. I mean, that's how cdk was built originally. And now when the synth is done, if the code is properly written, and there's no errors in terms of how we are actually creating that file, it will then create that file, the manifest file properly. And next, what I do is I do a CDK deploy. In this case, what it's going to do is, because I'm also doing an EKS deployment, right? So I'm actually creating an EKS cluster. It's going to actually create that also as part of it. So you're kind of seeing like two demos in one in this case, where as part of the setup, you're also seeing how a EKS cluster is being built. And of course, an EKS cluster does take some time because there's ENIs being brought out. There's things like the VPCs being created and instances being created also under the hood. Now, to give you an idea of what is happening behind the scenes, if you're using this as part of the whole CDK stack to deploy to AWS, you go to CloudFormation under the scenes, you'll see that the stack is already there, it's being created, and it's in progress, right? And that kind of like takes time. If you're looking at through the console, this is basically what you saw over there on the CLI is basically what you'll see on the console with much more information. And also, when you go to the EKS cluster over here, you'll see that the cluster has been created, and with the Kubernetes version 1.29 that was mentioned earlier. And this takes a bit of time, right? In this case, now while we wait for that cluster to actually get created, I kind of see a bit of the deployment side of things over here. If you notice also as part of the application, there's two parts to it, right? Now, this is more of a CDK thing. The idea is that we have like, as part of the demo, we have the chart and then the HTTP echo part, which is basically the application that is being deployed, right? The actual application that's being deployed. So you have the containers and you actually have the Kubernetes part also in place. This was added beforehand itself, just to give you an idea. So you can actually edit this or change this to whichever way you want to. Because when you do the boilerplate application with CDK in it, the CDK8s in it, you actually get a certain application that's actually there as part of this. Now you have the YAML file over here. Now that's available, which is cool. And you'll kind of notice now this YAML file is pretty straightforward because I've used some of the definitions that are already there in this case, because all I needed was just to create a deployment, right, for a very, very basic application. And what it's done is it's actually created all of this for me. Where I have like the specification, I have the service account tokens in place, the containers that are being deployed, because I'm using just Hello Kubernetes. It's just the basic Hello application that's there, and also it's also created the service bit also that allows me to actually have like the definitions that are available, the 8080 port, and then the deployment assets. So pretty straightforward, very simple application. It kind of gives you an idea how you can plug all this together as part of deploying the cluster and also deploying an application also, right? So I'll probably see if I can speed this up a bit Let me see. Right, okay. The deployment is done right now. And what I'm going to do is I'm just going to go to the application endpoint. And with this application endpoint, just open it up over here in the browser. And voila, we have the Hello World application over there. Yay. So we have the cluster running and everything's done. And the application's ready and set up. Now, next up, we're just going to check the QView endpoint also. That gives you that visualization of how all these resources are connected together within my Kubernetes cluster. So I'll just open this. And there you go, right? So now it's able to, I mean, because the chart worked, right? We actually injected it as part of the EKS setup. We are seeing how our applications are within the within this Kubernetes cluster in EKS. And you can kind of see that, okay, there is this deployment part and everything else, right? So there's not more to this that's actually required. Let me see if there's anything else. I mean, that's basically a view chart. And since it's not a demo for view chart, I'm not going to go for QView. I'm not going to go beyond that, right? So that gives you an idea of how you can actually bring all of this together. And then if you're actually using GitOps or anything else, there is a way to like bring and write more code for this. So in a nutshell, just to bring all this back together, right? The first thing you kind of saw was that cdk8s is an open source framework. It's used for modeling Kubernetes resources. It defines Kubernetes applications and also reusable abstractions in TypeScript, Python, and Java, and Go, right? Also, that there are core Kubernetes objects and custom resources that you are modeling in code directly. And this works really, really well with GitOps workflows, for example, because you can synthesize these YAML files like we saw in the second part, right? In the first part, we actually synthesized the application, the CDK application that was there because the EKS cluster and everything else was being built. And we were using cdk8s plus over there as part of, the initial part of what needs to be deployed. And then we had the second part, which is just the application that is being deployed directly, right? It's a very simple cdk8s application in that case. And then we saw the CDK8s plus library, which was basically with high-level abstractions. These are handcrafted constructs on top of CDK8s that auto-generates building blocks, right? So think of it as an opinionated construct, very useful if you want to like get started with something quickly with an opinionated approach. With a richer API with reduced complexity, but at the same time, it's something that you can then start moving off of and start building your own abstractions if you need to, because you would want to probably share that with other people in the team or in the organization also. Then with Amazon Q Developer, we kind of saw that briefly throughout the demo. You kind of saw how AI code is actually being generated and companion. I mean, it's a companion of sorts, an assistant of sorts for any code that is being generated, because you can then pick what you want, and with those suggestions, you can then see how you can be more productive faster, right? With the kind of code that you're building and writing. So gone are the days when you had to think, like for me, for example, personally, a lot of times when I actually have to write infrastructure code, whether it is with CloudFormation templates, whether it's with Terraform, whether it is with like CDKs, I actually have to think. I know what I want to build, but then I actually have to always keep thinking, okay, what is the first thing that I need? What's the second thing that I need? How do I actually write all this? And when it was in a configuration file with a YAML or a JSON file, it was much harder because you need to write it in a certain format, also in a certain sequence. But then the moment you get it in an abstraction with code, then it becomes a bit more easier, because then you know that the open source framework that you're using is going to take care of that, sequencing part and then linting part, and then making sure whatever you're writing and building is correct, right? Because if it is wrong, then it'll throw an error immediately, which means you go back and then you actually start rebuilding those, like writing the code again. So that in a nutshell is kind of like how you can see with cdk8s in this case. Pretty straightforward demo. I think it's great to kind of see this, and I would probably love to see more talks in the future around infrastructure as code and how we can simplify a lot of the complexity around these operation side of things in Kubernetes. I believe a lot of our organization have spent and invested a lot of time, engineering time, effort, and even finance and budget, and trying to make sure Kubernetes runs in a certain way. So any tools that helps us to reduce that complexity is always welcome, right? As long as it doesn't add on a certain level of complexity to our tasks also. So that's kind of like how you want to look at it with cdk8s. It's an open source project. It's already available. I'll I'll probably switch to the browser to the other bit of the help chat, but feel free to start putting questions if you have any as part of the chat. Let me just see if I can stop sharing and where is the help chat? Okay, here it is. So the other way of importing a help chart is basically this, right? So what you can do with CDK, this is basically the docs, the cdk8s.io website. You can actually have a look at it over here. Let me see like this. And so what you can do is that in your project, you can actually import a help chart directly, right? And the moment you import it in any language, right, whether it's Python or TypeScript, in this case, this is a TypeScript example, you can then import it directly, right, in your code. So in this case, what I've done is I've imported MySQL from Bitnami. And then afterwards, once I have it as an import, I can then start referencing it as a construct, right? It's an actual object within my code, which is pretty cool because for a lot of us who come from a programming background, having an object for a resource that is being defined helps us to start visualizing it in certain way and then writing like code and logic around that wherever it is needed. And that's kind of like where you can actually write things like this for values and architecture and so on and so forth, and then provision this. Let me add this. Just give me a sec. Yeah, cool. So that's basically what I had, and that's my LinkedIn. If you want to connect, if you have any questions, happy to take them right now.
So we have come to the end of the topic. So if there is any questions regarding this, you may feel free to ask it, or else you may just put in the chat box.
Yeah, Mohammed, thanks for the question. So with Amazon Q, you can generate test code as long as you're like creating it as, let's say, for example, you're writing a Python application or a Java application. If you import your test framework, right, as part of the project, and then let's say you create like an empty file called a test, and then you import those certain libraries, y- and based on the file that's open, by default, the way Amazon Q developer will work is based on the files that are open, it will then start understanding, okay, what I need to create. So what I usually do is for writing test code is I would import the basic test functions, and then afterwards I'll write a comment saying, okay, fine, give me a test function to actually test XYZ. Right. So I'll have those application files already open, and then allows me to then create those test code that's there. The other thing is you have this option now, which we just launched like in June, called at workspace. So it's kind of like a tag. When you do an at workspace, it then indexes your project, and then afterwards, based on that project, you can ask any questions, right? So in Q Developer within the IDE, you can also ask questions directly about your project, and then it will suggest certain things in the code, right? What you can do, these are the things you can do. So there are two ways you can do that: with inline suggestions within the file itself open, or in the extension chat within the IDE also. So two ways you can actually do this. Okay, so Fahad is asking a question if CDK and CDK8s. So CDK and CDK8s, you have to look at it as an abstraction layer for generating the template file, right? That's all it's doing. It doesn't understand what was the previous state or the next state for what you already have in your infrastructure. So what you need to do is, if you have so you start using CDK and CDKs for a fresh project, not for a project that already exists, right? When you do that, then invariably as part of the code and the application, you are then tracking those changes as and when it comes. But in the end, it's the Yes, Mohammed, do you have a question?
Um,
Yeah, sorry, thanks. So once you get that template, whatever you're using to apply that service that you're using to apply the template is the one that's going to do the diff, right? That's that service that it's whose responsibility. So whether it's CloudFormation or whether it's your Kubernetes cluster, for example, that's kind of like how you want to look at it. Because when you use CDK or cdk8s, you can also switch off the internet and then use it, and it'll still work because it's just locally running off your laptop. It's not doing anything beyond that. With CDK specifically, what happens is that when you do a CDK deploy, it's going to first check for your AWS account credentials and everything that's needed, and then afterwards it connects that project to whatever is being deployed in AWS. But that's about it, right? Beyond that, it still doesn't have visibility on, let's say, for example, you have done a certain deployment change later if you need to, which is why one of the best practices is that if you start with CDK or CDK8s, you want for a project, you want to make sure you continue doing that without trying to like go in and then change with another template and then applying that directly also. So that's kind of like how you want to look at it. If you want to know more though about the project and how it works, let me see if I can find something very specific about uh, um, because in the end it still uses CDK and let's see.
Is there any questions?
I
Are you
think there are some in the chat. I'll have a look at that. Yeah. Yeah, Fahad, let me get back to you on that. I'll paste it probably in the WhatsApp group later. I'll try to find. I believe there is something which talks a bit more about how this code is generated, right? And to be honest, you kind of want to look at it as that you can actually create a tool of this of your own also, right? Which allows you to then create such a manifest files, YAML files, or anything for CloudFormation. Also. But let me have a look. I believe I've seen something from a deep dive kind of perspective of what works. But this kind of gives you an idea of what it is, right? It's more or less is just allowing you to create those template files, but there's something like from the service on which you're going to deploy it, which has to own that responsibility of ensuring that the stacks of whether it's CloudFormation or whether it's the application on Kubernetes is being tracked, right? The differences are being tracked. But I'll get back on WhatsApp data for that. Is Amazon Q sharing my data with others? For example, I write for my company. Is it shared with them? No data privacy. You can have a look at the Amazon Q developer data privacy. But by default, when you use the free plan, you can opt out of the option of having your any code suggestion that is being created for you being used for future training purposes. But by default, but you can disable that for the free option, but for the paid version, it's never used. So as an organization, if you use Q Developer and using the enterprise pricing, your code is not used in any form. Let me just find out where the data privacy part is for you, so you can have a look. Just give me a sec. I did not. Okay, to be honest, I did not expect this session actually to go about Q Developer, but it was more like, okay, just to show you what can actually be done, but why not? Let me see. Does Amazon Q Developer use yeah, so you can probably just check this out. Let me see. Once I find the okay, here it is. So you can have a look at this for Q Developer, right? Mohammed, you can have a look at this link that I just shared. Can we get a sample use case or some repo where you have placed it? Yes. Let me just see if I can find it for you. Um, just a sec. Here you go. Here's the repo. So you can actually have a look at this code also if you need to. And Mohammed has another question: can we build template code? So template code is a challenge, Mohammed, and that's kind of like where I see CDK8 is actually helping out a bit more. So the challenge you have with YAML, like I said earlier, is that just because you have a key value file, it means different things to different programs, right? So if I take a key value file for a manifest file for Kubernetes, only Kubernetes understands that. But if I take that same file and then I put it to CloudFormation, it's not going to understand it because CloudFormation is expecting a different syntax. So uh, it is a request that has come in, and I know that the teams are actually working on it. But for now, you would preferably want to not use it for template files, Q developer. Instead, you would want to use it for code specifically, right? Or for SQL commands, for example, and things like that, right? And for writing JSON seed data, for example, right? If you're creating sample data, sample data that you want to use as part of your application in JSON, you can use it for stuff like that, but not for like creating actually configurations. Things like that for templates, for example. Cool. Is there any other questions? Feel free, please do bring in the questions. We actually have some more time if needed. And in the meantime, anybody else, you can probably connect with me on the. Uh, although I think some of you are already, I see some familiar names. So, any other questions? Is there anyone here who's using AWS and CDK in your organization? Okay. Is there anyone using AWS in your organization? Yes. Yes. Okay. That's good. And do you see something like CDK that's actually helping you from a Kubernetes deployment perspective, just to like reduce the complexity of managing manifest files? Okay. I don't see any other answers beyond that.
Sorry. Yeah, if you want to speak something, I
Sorry.
have just unmuted for Abdul. Yeah, I have unmuted the mic for Abdul if he want to share his experience, and same as Mohammed Benavilla.
Yeah. If you want to come on mic and share your experience, please go ahead. Okay. In the meantime, let me just find. I've actually also delivered a talk on Go and CDK8s. Let
Yeah,
me
am I
find that.
audible?
Yes.
Yeah, actually, thank you for this wonderful opportunity. I feel very grateful for connecting with such persons like you. As I am in the middle of as I am in the beginning stage of my career as a full stack developer, I'm currently working on projects related to AWS. So this session on Kubernetes really provide valuable insights for me. So thank you, Muhammad.
Thanks. Thanks, Abdulaziz.
Yeah, thanks, Rahul.
Yeah,
Wait, I mean, so I just pasted another link for a talk that I gave 2 years ago, almost 1.5 years ago, about CDK, CDK test. So that's also something you can refer to. That's a bit more advanced. It goes a bit in depth into a lot of things behind with CDK test, but it gives you an idea of what all can be done as part of the setup. Cool. Any other questions over here? Um, And I mean, probably I would love to hear later on WhatsApp, anyone in the future, in the coming weeks or months, if you try out CDK tests, you come back and then have to share your experience on the WhatsApp group. It's great to hear, especially when people attend a talk and then try something out. And then afterwards, come back and say, hey, this worked for me and this did not work for me, or probably I won't use it again. And that's okay. I mean, it's not a problem. I think the whole idea of the CNCF ecosystem with Kubernetes has always been that we can pick and choose our tools really well. Yeah.
Yeah, so it was such a wonderful session, and I hope that everyone is much, much interested to have more such sessions. And it's also sure that we got enough insights from a very experienced speaker, Muhammad Fazlullah. And I thank you, Fasilullah, for coming for us and taking this wonderful session in the name of CNCF Riyadh. And once again, thank you for all the attendees over here. Just note something that after the session, you will be getting a feedback email and kindly try to fill it. And we would love to hear from you people. You can reach us on Twitter, LinkedIn, YouTube, and our WhatsApp group as such. Okay. You can find the link in the chat box. And thus, I look forward to meet you people soon with another technical topic for discussion. Thank you all.
Awesome. Thank you all. Have a great evening.
Thank you first. Thank you for joining. Thank you all.